And this is the continuation. For some reason my video paused, so let us continue with solving for VF1. Simply writing down the equation first. And we do realize after writing down the equation that VI2 was initially 0, and anything multiplied by 0 cancels out that entire term. So merely we're just going to make a substitution, quite simply. So M1, 0.3 minus M2, 0.6, all over 0.3 plus 0.6. And that will all be multiplied by VI1, which was 2 meters per second. And when I punched this into my calculator, got a negative 0.6667. So since I assumed that it was initially moving in the forward direction, that tells us that this is moving in the backwards direction after the collision, and that will be at 0.7 meters per second backwards. For the final velocity of that 300-gram train. And then we can also calculate, same process basically, just the other equation for VF2. So I'm going to jot it down quickly first. And again, I notice VI2 is 0, so that whole first term cancels out. So we will simply substitute in now all our values over here. So that will be 2 multiplied by 0.3 all over 0.3 plus 0.6. And we'll take that answer, multiply it by 2, 1.3333. One significant digit, so the second train, a 600-gram train, after the collision, will be moving 1 meter per second forward. And that's really, in a nutshell, how to do these types of equations, these types of questions and problems. Always make sure you describe or define which direction is positive, especially if you have two objects moving in opposite directions initially instead of at rest like in this one.